Good day everyone, I am Mark Lawrence Asconde and I am here to discuss about the Kirchhoffs Voltage Law or the KVL. According to this law, the sum of all voltage gains with respect of any particular direction along a closed loop circuit is exactly equal to the sum of all voltage drop. The idea of KVL is that the sum of all voltages in a closed loop is equal to 0. So, to have a closer look about the concept of KVL, I prepared some circuits for us to understand it more. So for this circuit, I will show an example of closed loop, wherein we will try the KVL. So for this closed loop, we can see 4 elements. So for these elements, if the voltage is from higher potential to lower potential, I will use it as a positive voltage, otherwise it is negative. So using KVL in this closed loop, we will have 4 volts plus 1 volt plus 5 volts going back to negative 10 volt and equating it to 0 because of the definition of the KVL. And because of this equation, we can prove that the summation of all voltages in a circuit or in a closed loop is equal to 0. Because 4 plus 1 plus 5 is equal to 10 minus 10 is equal to 0. For this circuit, we are asked to find the voltage drop in the 200 ohm resistor. So, using the KVL in loop 1, we will have negative 1.5 plus the 100 ohm times the current flowing into it, which is the I2. And we will set this as our equation 1. Now, using KVL at loop 2, we will have 9 volts plus 200 ohms times I1 minus 100 times I2 is equal to 0. And we will equate it to 0 and set this as equation number 2. Now, solving equations 1 and 2 simultaneously, we will get I1 and I2, wherein I1 is equal to 37.5 milliamperes and I2 is equal to 15 milliamperes. We are asked to get the voltage drop at 200 ohm resistor. So let's recall the Ohm's law. It was stated that voltage is equal to the current times the resistance. Now, substituting all the values, we will have V is equal to 37.5 milliampere times the 200 ohms. Now, we will have 7.5 volts as the voltage drop at the 200 ohm resistor. So for my next example, we have a circuit in the time domain. Here, we are trying to find the voltage across the resistor, the inductor, and the capacitor using the Kirchhoffs law. First step in solving this circuit is by converting this circuit to phasor domain. So converting this function to phasor voltage, we will have 10 angle 0. Next, we will get the impedance for the resistor, the inductor, and the capacitor. Recall that the impedance of resistor is the same in the both domain. So for the resistor, we will still have the 90 ohms. Recall also that the impedance of inductor is equal to J omega times the inductor. Now, substituting all the values, we will have J times 2000 times 32 millihenry is equal to 64J. Now, recall that the impedance for the capacitor is 1 over JWC. Substitute again all the values, we will have 1 over J times 2000 times 5 microfarad. We will have negative 100J. We can now use KVL in this circuit to determine VR, VL, and VC. So applying the KVL at this closed loop, we have negative 10 angle 0 plus 90 ohms current I1 plus J64 current I1 minus J100 current I1 is equal to 0. Solving for I1, we get I1 is equal to 0.0958 plus J 0.0383 amperes. Observe in the circuit, all currents in the elements are the same. So we can assume that I1 is also the same as IR, IL, and IC. Now, we will solve for the voltage drop of the three elements. To start with, we will solve for the VR. Recall the Ohm's law, wherein voltage is equal to the current times the resistor. Substitute all the values, we will have times the 90 ohms. We will have for the VR is equal to 250 over 29 plus J 100 over 29 volts. And this will be the voltage drop in the resistor of 90 ohms. Next, we will find the voltage drop in the inductor. Again, substitute all the values, we will have times the impedance of the inductor, which is the 64J. Getting the value of VL, we will have 640 plus over 261 volts. And this will be the voltage drop in the inductor of the circuit. So lastly, we will now compute for the voltage drop in the capacitor. So again, remember the Ohm's law. Substitute all the values, we will have multiply by the impedance of the capacitor, which is negative 100J. So the voltage drop in the capacitor is equal to